In our project today, we're going to talk about tourism trade balance. This is our team, and this is our agenda for today. The global tourism economy depends on the balance between money earned from tourists and spending abroad by residents. Our goal is to understand the factors affecting this balance and help predict whether a country ends a year with a tourism trade surplus or a trade deficit. We will be testing four hypotheses: arrival intensity matters, spending quality over quantity, runaway outbound spend hurts, and small countries feel the swinging more. And for this exercise, we found four data sets: the tourism arrivals by country, international tourism receipts, international tourism expenditures, and the world population by country, all of this at the World Bank.
For data flow model, we load all of our Excel sheets into Databricks, and then once that's completed, we transform, clean, and melt, and then we join by our index, in other words, the country and the year. Once that is done, we have a single source. Then we are able to handle our nulls, calculate our balance column, and our z-scores for standardization. And then after that, we're able to upload into our Spark data frame as a delta table in SQL. And then finally, with that information, we can now utilize it for data visualization and ML models.
This slide just shows the code of our pre-processing step where we loaded the data from our four data sources, performed a transformation and cleaning, and ultimately ended up with our SQL table that we can use in Databricks for all the subsequent tasks.
This is a raw data source in which every sheet has a country name and a year. The only thing that will be different is their indicator name, which is pretty much just their measure. So for example, for our arrivals Excel sheet, it will be the number of arrivals. The structure of our data source, each one of them does have some similarity with regards to the year and the country. The only thing that is different is that every sheet has its own separate measure corresponding to the year. So before we join our data, the main transformations that we made was we obtained only data from 2015 to 2020, transformed the indicator name to our measure name. We melted the year columns into a single year column, allowing each entry to be a different year for a corresponding country. We transformed the metrics that have text to numeric, and then finally we created that index of a country year format, allowing joins for all of our sources. After our join, we have to figure out exactly how to deal with nulls, in which rows that have 2 or more null values will be a low quality flag. If a country has 5 out of 5 entries, the entire country will be removed since all of them are low quality. Everything else, if not 5 out of 5, with null values, were removed as well. Rows with one null were replaced with an average based on a certain country if information was provided, and anything else was replaced with a 0. Once that was completed, we would round our numerical values by 2 decimal places. We created a new metric titled our balance, so our receipt minus expenditures, and then finally we removed our non-countries and spell check countries. Once that cleaning was done, we decided to standardize our metrics by doing z-scores for every metric, allowing for ML models and data visualization to talk to each other in an apples-to-apples method. And this is our final dictionary, looking at the country name, year, index, arrivals, receipts, expenditures, population balance, and then finally the z-scores of all of those measures.
For this section, I will go over the various Spark SQL queries and visualizations that we did as part of this project. These were somewhat exploratory in nature to see what types of various queries and visualizations we can come up with and to see what may or may not help provide insights from within our data sets. This first slide demonstrates how to analyze the top 10 countries by their average tourist receipts to expenditures ratio using Spark SQL and visualize results with Python. On the left, you can see the code. We start by importing Spark SQL and matplotlib. Then we wrote a Spark SQL query to calculate the ratio of receipts to expenditures from our data set, grouping by country and sorting in descending order. The result is converted into a data frame for easier plotting, and the visualization, matplotlib, was used to create the horizontal bar chart that you see on the right. This next slide is a visualization that represents how we can visualize 2 different metrics over time. In this case, the receipts growth percentage and the population growth percentage for the United States using pure Python. The query can be altered to represent any country within the data set, and a drop-down input for a user to be able to select that country would have been a more optimal solution, but we could not get that working correctly within Databricks during the project timeline, unfortunately. We use subplots to create the base figure and twinx to add a second y-axis Different colors were used to visually separate the two lines, making it easier for the audience to distinguish between the two. One insight that I think stood out real nice from this visualization is that while the population growth remained relatively stable for the US, receipts growth sharply declined around 2020, likely due to that major external shock called COVID-19 global pandemic. Slide 3, this shows another use of Spark SQL for data extraction and Python for the visualization, showing the top 10 countries by arrivals per capita. The year is configurable within the query, and again, ideally we would have had this as a user selectable input that they can change on the fly, but we could not get that working. When building this query, we found that we had to filter out any rows where arrivals and population were null or zero to make certain that it used clean data for the visualization itself. We converted the Spark data frame into a pandas data frame to use for the visualization, and the visualization provides the user a means to quickly see that small island nations like St. Kitts and Nevis and the Bahamas all have very high arrivals per capita, reflecting their strong dependence on tourism relatively to their overall small populations. Slide 4 is an example of how Spark SQL can be used to analyze and display tabular data within a Spark environment. The query on the left shows the receipts share percentage by country, and the results table on the right obviously shows the output of that Spark SQL operation ordered by year and country. As you'll see next, this query was also used in a visualization here that I'll show. This slide builds on the previous slide, albeit with a visualization of those results from the prior query. From the receipts share percentage calculated earlier, we can see how it trends over time for different countries. This visualization required some research and some tweaking to get it to present effectively and was quite a challenge, if I'm being honest. I felt this was a good example of how to leverage the powerful visualization options within Python.
Hi, this is Derek. In this next section, I'll be covering the machine learning modeling phase of our project. We tested 5 different models, starting with logistic regression as a sample baseline, followed by random forest, gradient boosted trees, a linear support vector classifier, and finally a multi-layer perceptron neural network. For each model, I'll briefly highlight the approach, share the accuracy results, and show a few key visualizations. For our first model, we used logistic regression, a simple model that predicts outcomes based on a linear relationship. It's often used as a baseline, and in our case, it achieved about 48% training accuracy and about 71% test accuracy. The actual versus predicted chart shows the model aligned fairly well with true outcomes, and the ROC curve shows decent separation between classes. This gave us a good starting point before testing more advanced models. For our next model, we used random forest. Training accuracy was about 48% and test accuracy was about 77%. The model predicted positive and negatives fairly evenly, and the ROC curve shows strong class separation. For this model, we used gradient boosted trees. Since GBT only supports binary outcomes, we couldn't measure training accuracy, but our test accuracy was about 76%. For our fourth model, we used the linear support vector classifier, or linear SVC. This model is useful for finding a decision boundary between two classes. Due to the dataset limitations, we were unable to calculate training accuracy because Spark's linear SVC requires exactly 2 classes. However, based on our test results, linear SVC achieved about 74% accuracy, which was fairly strong compared to some other models. For our final model, we used a multi-layer perceptron, or MLP, which is a type of neural network designed to capture complex patterns in the data. After training, the MLP model achieved a training accuracy of around 78% and a test accuracy of about 78% as well, making it our best performing model overall. This strong performance highlights the value of using more advanced machine learning techniques on our tourism dataset. Our models successfully predicted tourism trade outcomes using features tied to arrivals, spending, and population. They confirmed all 4 hypotheses, including the impact of outbound spending, arrival intensity, and population size. Smaller countries were more sensitive and spending behavior mattered more than volume. The models didn't just predict, they explained what drives tourism balance.
In practice, this means we should stop chasing visitor counts or average spend alone. Instead, keep a close eye on the ratio of expenditures to receipts and on net balance per person, especially in smaller markets where each visitor makes a bigger impact. Those two metrics should guide our planning and policies going forward. We face many challenges. Datasets contain missing data. Databricks community doesn't allow group sharing, and notebooks were getting detached often. Different degrees of technical skills in the group presented various challenges, and we needed additional data sources for population to compare countries.
So this code right here is pretty much our compiled code between all of our teams, between the data transformation, the data visualization, and our machine learning. So first things first, these first couple of files are just transforming every single Excel file. So we have arrivals, we then now have receipts, expenditures, and then population. Once that is done, we join that information, as you can see right here, with every country and year being one record. After that, we get rid of our nulls, replace our nulls, and then also double check if we have a country in our data frame, as well as spell check, in which we have our cleaned version right here. Once that is done, we are able to get our z-scores for our data viz and our machine learning modeling. And after that, what we can do here is upload into a SQL table within Databricks, allowing us to easily extract the information for our machine learning and our data visualization. So what we have here is this was provided from our data visualization team, so Jeffrey, in which we are able to look at exactly our top 10 countries by tourist receipts to expenditures. We're able to look at a descending total change. And then after that, we're able to look at receipts and population growth percent over time within the United States. And then what we have here is a top 10 countries by arrivals per capita with regards to all the code. And then what we also have is a receipts share percentage by country. Here is the code on that. And once we're done with that, what we're now able to do is transfer over to our machine learning team, which is composed of Claudia and Derek, in which we are able to load our data, load our delta table right here, being able to have a binary label of if a receipt is greater than an expected. And then after that, what we can do is prepare our data, create our models, and then our final output is pretty much our accuracy within our test for our modeling, and then our training, being able to see exactly is our model overfitted. But that's pretty much how we utilize this project with our code.
That concludes our group's presentation. We hope you found it enjoyable. Please let us know if there's any questions. Thank you very much.